This is Algebra 1, Semester 1, and it is the unit called Equations. It's 01, and it's the lesson number 7, Variables on both sides of the equations practice, all right? Let's put a practice here. It's on creatormath.com under the Algebra 1 tab. You might have to Google creatormath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So to illustrate what that means, this is the website here. It's creatormath.weebly.com. Google that. Here's what the home page looks like. Everything you need to know about the composition book, the due dates, the instructions, the videos to watch on how to do it is under my picture on that home page. Scroll down till you see large letters, composition book, and a picture, and follow those directions, follow the due dates. You should have a 90 to 100% on your comp book if you are following those. Now we're going to go to notes, videos, practice problems. It's all under the Algebra 1 tab. Notice there's the Vocabulary Algebra 1 Practice Study PDF right here. If you're not getting 100% on your vocabulary practices, you probably don't know that you can open this PDF and search it. Google how do I search a PDF with the device you're on. You should be getting 100% on those vocabulary practices. We're going to scroll down to find the table of contents we need. We're in Semester 1 for this particular video. So Semester 1, table of contents. This should have all been copied onto pages 2 through 6 of your composition book. If you haven't done it yet, stop what you're doing now and go ahead and complete that. We're going to find equations. Here's equations, the first unit. These are all the lessons within that unit, and we are on number 7, variables on both sides. So here it is right here, number 7. Variables on both sides of the equations, and here are the pages in your comp book where these notes go. Here's the notes link. There's a problems link, and this video will be on the video solutions. So if you click notes, you're going to copy this into your comp book first on those pages. Please don't follow this video for the pages, but go find the original table of contents. Here are problems you're going to go ahead and copy in. This is harder to tell what's going on, but I need you to have sort of a background. Notice the way the equals are lined up. That's going to help you understand the actual problem sets we're going to do now. The vocab will help you, like what is a variable? It's a letter or symbol which represents any number. An equation, there's two sides with an equals in between them. Smaller number, remember that -5 is smaller than 5. Break-even point, that's the point at which the benefits equal the downside. So let's say that we started a business and we put in $500 and we make our first $500 back. We're now at break-even point because we haven't made any money yet. Once we make $501, we now have $1 in profit, and therefore we are now making money. So with these notes copied into your composition book, we're going to now turn to the problems and give you a video solution of this. So this is our 7th lesson on equations. This is pretty advanced. If you haven't seen those prior, you're going to go back and do it because I'm not going to take too much time on these. I'm going to assume you know some of the basics already from those prior lessons. So I'm going to rewrite the problem right here because sometimes when it's typed, you'll see things like 1/7. It looks a lot better to my eye to see it this way than 1/7. We're going to use distributive property first here and possibly here. This is 4 times x is 4x. 4 times 7 is 28. We're keeping the equals lined up. Here, because the 7 divides into the 21s evenly, or I have an integer once I divide it, I'm not going to worry about this denominator 7. If I do have a denominator later, I'll show you how to get rid of it. And this one just happens to be 21 divided by 7. 21x divided by 7 is 3x. So 21 divided by 7 is plus 3. So notice we have variables on both sides of the equals. We're going to subtract the smaller number of variables from both sides. In this case, 3x is smaller than 4x, so we subtract 3x from both sides. It makes 3x minus 3x is 0. We have a 3 still on the right. We have an equals in the middle. We have a 28 that comes down, and we have 4x minus 3x is just x. We're going to subtract the 28 from both sides and come come over here, and we're going to say there's an x on the left, there's an equals, and we have negative 28 plus 3 should be negative 25. So x equals negative 25. We're looking right here, and we're selecting the correct answer. Remember, mine will be on the top always, but yours will be mixed up and randomized, right? Let's go to the next. This is 1/3 times 9x plus 3 equals a negative 2 times x minus 8. So this 1/3 here, it actually does divide by 9x and by 3. It goes into those in an integer fashion. I'm okay with that, but I'd kind of rather model for you what to do if it doesn't. Let's multiply this whole thing by 3 over 1. It's going to put a 3 here and a 3 here. So you're going to have multiplied by a 3 and multiplied by a 3. So this is 3 over 3, which is 1. And that would leave me with 9x plus 3 on the left. The equals is in the middle. This one's going to be negative 2 times 3, which is going to give me negative 6, and still be multiplied by this quantity. So we're not done with distributing this over here yet. But notice there's no more 3 in the denominator position. All right? So 9x plus 3, let's repeat this. Let's do negative 6 times x is negative 6x. Negative times negative is positive, and 6 times 8 is 48. Let's take care of the smaller number of x's, and in this case we're going to add it to both sides because it's literally a negative number, but it is smaller. Negative 6x is smaller than 9x, right? So we added 6x to both sides. Disappears from here. 9x plus 6x is 15x, plus 3 comes down, and we have a 48 on this side. So we're going to subtract 3 from both sides, minus 3, and now I can come over here and say that the minus 3's disappear. So there is a 15x on the left, an equals sign, and 48 minus 3 is 45. I'm going to divide both sides by 15, and x equals 45 divided by 15 is 3. So x equals 3. We're going to come over and select the correct answer choice. And this might be a relatively easy one to plug back in. Maybe not. Let's do it later. So I'm going to keep moving forward. This one is x minus 10 equals negative 3 times x minus 2. So let's distribute first. Negative 3 times x is negative 3x. Negative times negative is positive, and 3 times 2 is 6. So x minus 10. So I'm going to, because this is the smaller number of x's, I'm going to add 3x to both sides. And we could mix it up. We could have subtracted 1x from both sides. We'll get the same answer. This is just a little bit cleaner because it keeps the negative out of the x's. So this disappears. 3x and x is 4x minus 10 equals 6 plus 10 here plus 10 here. Let's come over here. These will disappear, so 4x on the left equals a 6 and a 10 is 16 divided by 4, and x equals 16 divided by 4 is 4. So do we have a, we don't have it, but I'm going to make sure that this is x equals 4, and that's going to be the correct answer. All right. So by doing this a little bit ahead of you, then I can go back and correct those before you get to them, all right? 3x minus 2 equals 5x plus 2. Let's subtract the smaller number of x's from both sides. So 5x minus 3x is 2x. There's a plus 2 over here. There's an equals right in the middle and a minus 2. Now we're going to subtract 2 from both sides. Gone. Negative 2 minus 2 is negative 4 equals 2x. Let's go over here. Let's divide by 2 on both sides. And so we're going to get x here, because 2 over 2 is 1, 1 times x is x, equals in the middle, and negative 4 divided by 2 is negative 2. And remember, these can be flipped. It's legal to flip it, and if it was an inequality, we would flip the inequality too, and equals just flips. It's not supposed to be a z, you guys. I just can't pick up my pen. It's an equals here. All right, so x equals negative 2, circle the correct answer. And let's plug this one back in. If it's negative 2, right? 3 times negative 2 would be negative 6. Minus 2 would be negative 8. So this says negative 8. Let's take negative 2 here. 5 times negative 2 would be negative 10 plus 2 would be negative 8. So sure enough, negative 8 equals negative 8. This answer is correct. It makes this statement true that this side is equal to this side. That's plugging it back in to check your answer, which we teachers always tell you to do, and then you watch me solve problems, and I don't do it. Yeah, if it solves out clean, I mean, I gotta be honest, I get lazy and I don't do it. So it is your option to do, especially if you're questioning the answer. I'd go back to do it, and you will see me do it just to try to model it. Negative times negative is positive. 20x, negative times negative is positive is 10. 4x comes down. Negative 7 times negative 3x is positive 21x. Negative 7 times negative 10 is positive 70. So we've got a bunch of things going on here. We have combined like terms. A 4x and a 21x becomes 25x. You still have the 70 here. We still have an equals in the middle. And we still have 20x plus 10 here. Let's subtract the smaller number of x's from both sides. Gone. So we have, whoops, a 10 here. A 10 here. 25x minus 20x is 5x and plus 70. So minus 70 minus 70 is going to go like this. Let's go over here. The 70s disappear. We have negative 70 plus 10 is negative 60 equals 5x. All right, divide by 5 on both sides. Gone. X equals negative 12. So is that one of our answers? Yes. And remember, you can flip this. I always like to clean it up and say x equals negative 12. But the statement works, negative 12 equals x, and x equals negative 12. That is, oops, sorry guys. Whoop. So just to recap, the 70s disappear here, right? Because 70 minus 70 is 0. So you get a 5x on the right. Negative 70 plus 10 is negative 60. We're going to divide both sides by 5. The 5's disappear, so it's x. And negative 60 divided by 5 is negative 12. So we can flip it and say x equals a negative 12. All right, and we circled that right here, negative 12. All right, sorry about that. I get carried away, and I don't realize I'm writing off the page. All right, so let's try this one. Negative 4 times negative x minus 4 equals negative 4x plus 6 times 2x plus 6. Looks gnarly to start with. Let's use distributive here and distributive here, property. Negative 4 times negative x is a positive 4x. Negative times negative is positive. 4 times 4 is 16. Negative 4x. 6 times 2x is plus 12x. 6 times 6 is plus 36. We have a 12x minus a 4x, which is an 8x. The 36 is still here. The 4x plus 16 comes down. So I'm going to subtract the smaller number of x's from both sides, minus 4x on both sides. Right? Gone. So let's go over here. We have 16 on the left equals 8x minus 4x is 4x. And 36 still is hanging on. All right, we're going to subtract 36 from both sides. So 4x on the right equals 36 is negative plus a 16, so negative 20 if I have that right. Divide both sides by 4, and x equals negative 5. Negative 20 divided by 4 is negative 5, and I can flip it and say x equals negative 5, and if I'm on track here, good. Right, looks like we got 2 more left. Let's keep plugging away. Negative 2 times x minus 6 plus 2x equals 3 times negative 3x plus 10. Distributive property. Negative 2x, negative times negative is positive, 2 times 6 is 12. This 2x just comes on down, the equal stays lined up if at all possible. Negative 3x times 3 is negative 9x. 3 times 10 is plus 30. And I'm just glancing here, did I get all these signs right? I start to get lazy or tired or careless or whatever, and I start to make mistakes. Negative 2x and 2x disappears. They're gone. So I literally, this isn't actually variables on both sides once those disappear now, right? But I guess it was when we started. So let's subtract 30 from both sides. Gone. Negative 9x equals negative 30 plus 12 is negative 18. Correct me if I'm wrong. So we're going to divide both sides by negative 9. And then come over here. Negative 18 divided by negative 9 is a positive 2. There's an equals right here. Negative 9 divided by negative 9, these disappear to 1. And we're left with just x equals 2. And if we got, wow, that was pretty messy, and I'm kind of scared I didn't do this right. 2, let's see. This one's going to be a little bit tougher. 2 minus 6 is minus 4, times a negative 2 is 8. And 2 times 2 is 4, so 8. This looks like 12 on this side, all right? And I'm doing it pretty quick, so I might have to do it twice, but it looks like 12. Negative 3 times 2 is negative 6, plus 10 is 4. 4 times 3 is 12. So I get 12 on both sides of this equation when I use the x equals 2. That is a check for me. I'm happy. I'm going to move on. You might have to write all that out, okay? If you need to write it out, all right? Do what you need to do to be successful. I'm going to model most things, and then at some point, I'm going to model moving on, because at some point, you are trying to do work in your head. You are trying to write less. You are trying to move through this in a faster fashion, all right? I know we teach you to write everything out, but at some point, it's time to move on and time to write less, okay? You do actually pick up a proficiency. Once I have a 27 here and a 9 and a 27 here, I'm not going to multiply through by 9 like I did on the prior example, because this 9 divides evenly into these 27s. 6 times x is 6x. 6 times 7 is 42. And 27, so what we literally have, maybe if I can write this out, this is 5 times 27x over the 9, plus 5 times 27 over the 9. The 5/9 gets multiplied by each of these terms, right? Now I can simplify. This 9 goes in here 3 times. This 9 goes in here 3 times, all right? So we're going to bring down the 6x plus 42. This now, the 9's gone, the 27's gone. It's a 5 times 3x, which is 15x, and it's a 5 times 3, which is 15. I'm going to subtract the smaller number of x's from both sides. 42 equals 15x minus 6x leaves us with 9x plus 15. I'm going to subtract 15 from both sides. 9x equals 42 minus 15. Well, let's see. 40 minus 15 is 25, plus 2 is 27. So it looks like 27 here. I'm happy about that because it divides evenly into the 9. So divide both sides by 9. X equals 27 divided by 9 is 3. X equals 3. Right, I'm okay with that. Make sure you guys are matching up the title of the video with the problem set you're working. Otherwise, this doesn't work right? This is Algebra 1, Semester 1. It's the first unit called Equations, and it's the 7th lesson within that called Variables on Both Sides, Equations Practice. Right, it's on creatormath.com under the Algebra 1 tab, and I hope this helps.